Hello, welcome. Our project was on the Internet of Things Autonomous Vehicle Express Lanes and was created by Leah Mitchell and Mohammed Afaran. To give you a brief overview of what exactly express lanes are, I'll start with an example scenario. So imagine you're going about your daily routine and you hit rush hour traffic jam. With an express lane, you have the option to buy time blocks to get you to your destination quickly and efficiently. Now add in the factor that we're on the brink of having fully autonomous vehicles out on the road, and they'd be able to automatically merge into the express lane for us. That's a whole new ballgame. With the correlation of the population increasing, there has been an increase in traffic jams as well. If we're able to integrate sensors and devices into our infrastructures, we have the potential to reduce high volume traffic. Think of the express lane solution as if it were a toll road. It would create revenue for the government and reduce taxes for free road drivers. This is our hardware that we used for the project. You can see the station, server, and the piCar all located in respective order. This photo is a close-up of our station. You can see the FSR, the RFID reader, and the webcam all connected through the Raspberry Pi. This is the SunFounder piCar S. You can see the buttons at the top and the RFID card located at the bottom. So I'll start out with the piCar. It has 3 options. Normally it would be 15 minutes, 30 minutes, 60 minutes, and use whatever time you have left on your account. When on the road, this would be displayed on your center console, giving you the options to buy 15 minutes, 30 minutes, and 60-minute block of express lane time. This adds 1 second, and the 10 seconds are from over there. So hit this and run it. Now it's going to go for 11 seconds, stop, and then reverse for 11 seconds back to its starting point. You can see the 11. So this is the middle. Now it's done, and it's sent back the finish time to the server. Here's the last one, 0. To help explain how all this would work, here's a flowchart diagram. To start off, the vehicle would be in the free lane. The user would have to purchase a block of time using the car's center console to merge into the express lane. Once the user purchased a block of time, it would update the list on the server through SSH. The car would trigger the FSR, which would then send a signal to the Raspberry Pi station. The station would then request for an updated list from the Raspberry Pi server through SSH. And then the RFID scanner would have 1.5 seconds to scan the car's tag. If the RFID tag was not scanned within the 1.5 seconds, or the tag was invalid because there was not enough time on the account, then a picture would be taken using the webcam connected to the Raspberry Pi station, and an email containing the picture as an attachment would be sent to authorities. Now coming to the station side of things, we have the force sensor and the RFID reader. And here's the station. It's connected up to, here's the FSR. It's in a voltage divider layout, and the V out is actually the V in for the non-inverting op amp. And then we have GPIO pin 4 taking the output from the non-inverting op amp, and I'll show you that. We have 4 RFID tags. These ones over here are marked as invalid, or they do not have time on their accounts. And these ones are good. Waiting for next car. I gotta do this quick. I'll show you. Alright, that's an example of time limit exceeding, so it's waiting for the next car to pass again. This is an invalid card. Waiting for next car. That is a valid ID. Valid ID. You'll see invalid ID or no purchase time, alerting authorities. This isn't the right one. Here it is. That would be the car. Now over here would be the authority station. Download this. There it is.